Hi, thanks for joining me. We are going to discuss systems of equations, and we're going to solve these by the elimination method. Now, some places I've seen say the addition method. I've always heard it as the elimination method, but they mean essentially the same thing. It's the same method. There is another way to do this, and that's the substitution method. You can also do these by graphing, solve by graphing, but the graphing really is not the way you should do most of these because it's not really a reliable way to figure out your answer. It works in certain situations, but there are videos covering the other methods, so feel free to check those out. So, number one, solve each system of equations by elimination. Eliminating means to get rid of, right? If you're going to eliminate something, you're going to get rid of something. And so what you're trying to do here is when you're solving a system of equations, you're trying to figure out what point or points would make both of these equations true. So what is the solution to both? First thing we want to do is try to add these together and see if we can eliminate any of the variables. If you see right here, let's just say I wanted to add these equations together. Let's look and see what would happen. So if we add like terms, we have 2x plus x, that would give us 3x. And then we have y and a negative y. Do you see that those are opposites? If they're opposites and we add them together, those will zero out. They'll cancel out. So there's no more y anymore. That's what we want to happen in the elimination method, is we want one of the variables to cancel out. And then negative 8 plus a negative 1 is negative 9. Do you see the benefit of that? If one of the variables cancels out, then we're left with only one variable. And if we only have one variable, we can solve and figure out what that variable is. And so that's what we're going to do here. To solve, this is multiplying 3 times x, so we undo with division. 3 divided by 3 is x, and then negative 9 divided by 3 is negative 3. So x is 3. Now, be careful. Sometimes people get in a rush and they box this in and say, hey, that's my answer. Remember, the answer to a system of equations is an ordered pair. We only have the x value. We need a y value to go with that. So what we do is we plug in this x to either of the first two equations and figure out what y is. And then we'll have the y value. So in my mind, the second equation looks easier, so I'm going to do that. So I'm going to plug this in to the second equation, but if you like the first equation, you can plug it in there. It doesn't matter which one you choose. So x minus y equals negative 1. I'm going to plug in the negative 3 for the x, and then I'm going to solve for y because now only y is left. So let's get rid of the parentheses. Negative 3 minus y equals negative 1. To get rid of the minus 3, I'm going to add it to both sides. So that will give me negative y equals negative 1 plus 3, 2. And again, I need to get rid of that negative, so I'm going to divide by negative 1. That'll give me y equals negative 2. Now I'm where I need to be. I've got an x value and I have a y value, and together I can write those as an ordered pair. Remember, the x value always comes first, so negative 3, negative 2 is the answer to that. If you watched my video on solving by graphing, that's actually the same problem I do by graphing, but this is the way you would use the elimination method to solve. All right, so let's see. That's kind of like the best case scenario. Number one is that you just take the two equations that they give you, you immediately add them together, and one of your variables cancels out because they're opposites already. If you look at number 2, if we add these together, you'll see that neither of these are opposites. We have a 3x and an x, and a 5y and a negative 2y. They're not going to zero out. So we can't simply add them together because neither of the variables will cancel out. In this case, what you have to do is scale up one of the equations by multiplying by some scalar, by some number, so that one of the variables is opposite one of the other variables in the other equation. In this instance, I'm going to pick the x's, and you can pick either variable that you'd like. The reason I didn't pick the y, if I look at the y values, I can't multiply 2 by something to get 5. So since I can't multiply 2 by a number to get 5, and I'm talking, I mean, I could do a fraction. I don't want to do that, right? I'm not going to choose the y's. Okay? But for 3 and 1, I can simply multiply 1 by 3, right? And that gives me the same number. So that's why I'm picking the x's. Keep in mind that you want it to be the same number, but the opposite sign, okay? So this equation, I'm going to multiply by 3, so it'll be the same number, but the opposite sign. So I'm going to multiply it by -3. And I'm going to distribute that to every piece on both sides. So let's see what I get when I do that. The top equation I'm leaving the same. 3x plus 5y is equal to -11. The second equation, I'm going to multiply everything by -3. So it'll be -3x, right? And then, so this is times -3, this is times -3, so that'll be a positive 6y. And then -3 times 11 is -33. Do you see that now your x's are opposites? You have a positive 3x and a -3x. That's exactly what you want. And now you want to add your equations. So x's cancel out, and we get 5y plus 5y plus 6y is 11y. -11 plus -33, they're both negative. Add and keep the sign, so we get -44. We only have a y left. So now to solve for the y, we divide by 11. We get y equals -44 divided by 11 is -4. So that's great. Remember, this isn't our solution. It's just one part of our solution. But I'm going to highlight it so I remember I have my y. Okay, now what? I need to find the x, right? So I'm going to take this y and plug it into one of the equations and solve. In my opinion, the second equation looks easier to use, so that's what I'm going to use. So x minus 2y equals, nope, not -11, just 11. Plug in -4 for the y. So x minus 2 times -4 is equal to 11. So it's -2 times -4, that'll be positive 8. So x plus 8 equals 11. Now I need to subtract 8. So I get x equals 11 minus 8 is 3. Okay, so now I have an x value and a y value. So I put those together to make an ordered pair. Remember, the x has to go first. It doesn't matter which number you find first, right? The x goes first in the ordered pair. The y goes second. So my solution is 3, -4. Okay, so before I do the next two examples, here's a URL for my reference. I use some of the examples from this OpenStax College Algebra textbook. Remember that there are plenty of examples in this textbook that you can do to see if you understand the material, and they give you the answers to the odd problems. So do some of them for extra practice. Make sure you're getting this concept down. All right, number 3. I don't have any opposites. My x's are not opposites and my y's are not opposite. So next what I want to do is try to figure out which one I can multiply easily to make opposites. So 2, I can't multiply that by anything to get the 5. 3, I can't multiply that by any whole number to get the 10. So neither of these are great options. If you can't figure out one of them to multiply easily to the other, then you're going to have to multiply both fractions. And it's kind of like finding a common denominator. You're trying to find a common number. All you want to do in that case is multiply them both by each other. I always pick the numbers that are smaller. So 2 and 5, if I multiply those together for the x, right here, 2 and 5, that would give me 10. If I chose the y and I multiplied those together, 3 times 10 is 30. So my numbers are going to be significantly larger. So I'm going to choose the x values. But again, remember, you can choose either variable. If I want to make these be the same number, I can just multiply them by the other. So the top one I would multiply by 5, and the bottom one I would multiply by 2. Because you see the 5 times 2x would be 10x. And on the second equation, the 2 times 5x would be 10x. Remember, you want to make sure that they're going to be opposite signs. Since they're the same sign right now, I need to multiply one of them by a negative. Doesn't matter which one, so I'm just going to multiply the top one by a negative. So let's see what I get when I do that. So -5, I'm distributing it for the whole equation. So that'll be negative 10x minus 15y, right? Because remember, I'm distributing it to every part of the equation, is equal to -5 times -16. That's going to be 80, right? And then on the bottom, I'm doing the same thing with the 2. So 2 times 5x is 10x. 2 times -10y, that'll be -20y. And then 2 times 30 is 60. Notice that it did work out for my x's because they're now opposites. One is a -10 and one is a +10. So I'm going to add the equations together. So the 10's cancel out, and I will have -35y is equal to 140. To finish, this is -35 times y. I'm going to divide by -35. So that'll give me y equals, and I believe that's 4. Oh, but it should be a -4, right? -4. Okay, so here is my y value. Now I need to plug that into one of the equations to find my x value. It doesn't matter which one, so I'm going to pick the first one. So the first one is 2x plus 3y is equal to -16. So 2x plus 3 times -4 is equal to -16. And now I'm going to solve for x. So we will have 2x, 3 times -4 is -12, is equal to -16. Add 12 to both sides to zero that out. And so we will have 2x is equal to -4. Divide by 2. And we'll see that x equals -2. So there's our x value. We now have found an x and a y. So we can write our ordered pair. Whoops. -2, -4. And remember that you can check your work if you'd like by plugging this point into each equation and making sure that it balances. If it doesn't balance, then you did something wrong, and you can check your work. Okay, number 4. Right here, you can see that this looks different. So actually, to me, when I look at this one, I think of doing the substitution method because x is already by itself in the top equation. But we're going to focus on the elimination method here. And so what I want to do for the elimination method is I really like the equations to be in standard form, meaning the x and the y are on the left, and then the constant is by itself on the right. So that first equation, I need to adjust it. So I have x equals 9 minus 2y. I want to move that 2y over to the left. And so if I do that, I will get x plus 2y is equal to 9. So I'm going to start by rewriting that top equation in standard form. Okay, and the bottom equation I have not changed. Look at the x's or the y's. Do you notice that they're the same number? All we need to do is change the signs on one of them. So what I can do here is multiply one of the equations, and again, it doesn't matter which equation, by a -1. And that will change the signs. So the top equation this time I'm choosing to leave the same, but the bottom equation I'm distributing a -1. So I will have -x minus 2y is equal to -13. And now that I have opposites on my variables, I'm going to add the two equations together. X and negative x are opposites, so those zero out. But look at what happens with the y's. Those are also opposites. That zeroes out. So what's left on the left-hand side? A zero. A zero is left, okay? So on the right-hand side, I have 9 plus a negative 13 is a negative 4. Do you see that I have no variables left? All my variables canceled out. So now I have a statement that says 0 is equal to negative 4. Is that true? No, it's not true. 0 is not the same as negative 4. This is a false statement. If you eliminate all of your variables and you come to a point where you get a false statement, this is no solution. So there's no solution to this system of equations. If you put these into slope-intercept form, meaning y equals mx plus b, you would see that these equations have the same slope, and that's because they're parallel lines. And so parallel lines never intersect, and so there's no solution to this system of equations. Okay, let's look at number 5. I think this is the last example I have. Yes, okay. So number 5, again, we've got two equations. We're going to solve by the elimination method. So they're both in standard form, so that's good. Now what I want to do is see if any of the variables are opposites already. They're not. But if I look at the x, I can see that I have a 1 and a 3, and it's going to be easy to multiply the top row or the top equation by negative 3. And I say negative because remember you want the signs to be opposite. Okay. So if I multiply by negative 3, remember you're distributing that to the whole equation. You're doing both sides of the equation. So that will be negative 3x minus 9y is equal to negative 6. The bottom equation, you're not doing anything with that. You're leaving it as is. Okay, now the x's are opposites, so we can add. X's cancel out. And look what happens. The y's are also opposites. Those cancel out. If you notice on the right-hand side, the constants are even opposites. Those cancel out. So we've canceled everything out. So what does that leave? That leaves 0 equals 0. So no matter if you cancel everything out on one side or both sides, you still have something to write. It's a 0. 0 equals 0. So now you have to decide, is that true or not? And that is a true statement, right? 0 is 0. That's true. So there is a solution to this. In fact, there are infinitely many solutions. This is actually the same line. One is a scaled up version of the other. So in other words, the bottom one is 3 times the top, right? If you multiply the top equation, by 3, you would get the second equation. So since this is actually the same line, when you graph it, infinitely many points satisfy both equations. All of the ordered pairs on the line satisfy both. So this one would have infinitely many solutions.